We have a cable made of copper. Its length is 1.2 kilometers, and the potential difference across the ends of the cable is 170 volts. Now, this cable is dissipating heat at a rate of 95 watts, and the question is, what is the diameter of the cable? Now, what is it that connects the voltage, power, and the geometry of the cable? That's basically resistance, right? So we're going to combine the resistivity formula with the power formula, but we want the version of the power formula that has resistance and voltage. Here's the general formula for power. So this works for any circuit element. But for a copper cable, because it acts like a resistor, we can combine it with Ohm's law to express power in terms of V and R. From Ohm's law, we have current equals voltage divided by resistance, I equals V divided by R. Let's combine the two equations to eliminate I. We get power equals V squared divided by R. Actually, next I'm going to isolate R because I'm going to combine this with the resistivity formula, which is another formula for resistance. So let me go ahead and isolate R from this one. We get R equals V squared divided by P. Now let's move on to the resistivity formula. According to this formula, the resistance of the copper cable is equal to its resistivity times its length divided by its cross-sectional area. So the cross-sectional area has a circular shape, so that's going to be equal to pi r squared, like so. Next, I'm going to set the right-hand sides of these two equations equal to one another and isolate the radius r. I know I'm looking for diameter, but then once I have the radius, I'll just multiply that by 2. Here I have combined the two equations by setting the right-hand sides equal to one another, and I have eliminated resistance R. Now let me rearrange my equation to isolate the radius lowercase r. Here I have the radius isolated. To find the diameter d, I will just multiply this by 2. Here's what the diameter is equal to. Now let's substitute the numerical values and calculate. For the numerical substitution, I looked up the value for copper's resistivity. And here's our result. Keeping two significant figures, we get 3.0 times 10 to negative 4 meters for the cable's diameter. So that's about 0.3 millimeters.